Okay, it's time to learn about geometric solids. The rest of the quarter, we're going to be learning about solids. So far, we've only talked about flat things like triangles and polygons and circles. Now we're going to start raising those things into 3 dimensions, and that's what geometric solids are. So this resource document will be in MinWeb under resources. If you haven't found resources yet, then you need to take a look at the post on the blog that explains that. And I can send it out if you'll email me if you're not finding it. But there is a certain way to look to find the resources that I've uploaded. They're there, they're definitely there. If you're getting a college support website, when you click resources, you're not clicking in the right area. So let me know if you can't find the documents. But first of all, let's talk about what a solid is. So like I mentioned before, we've only talked about things that we can draw on paper in 2 dimensions. A solid is a 3-dimensional object. It's something that includes that 3rd dimension, not just length or width, but also depth, or if it's something flat, height. So a great example of a solid is a Rubik's Cube. We look at it, it's got length and width on the bottom, but then it raises up into the air and it has length and width all the way across all of these levels. So when we work with solids, we work with surface area and volume. And there are formulas for finding the surface area and for finding the volume. So when we say surface area, what we're looking for is what is the total area of all of the surfaces of our solid. Think of it as if I was going to wrap this Rubik's Cube in tinfoil or Christmas paper. Exactly how much paper or foil would I need to cover each surface? Exactly, with none left over. So how do we find surface area? Well, surface area is just the sum of all of the surfaces of the solid. So in this case, if I think about a Rubik's Cube, I don't have a ruler. I do, I have my homemade ruler. I have my homemade ruler. But in this case, we don't have to use a ruler. We can just use Rubik's units. If we just say each one of these little squares is a Rubik's unit, then the area of the red side here, the area of the red side is 1, 2, 3 Rubik's units times 1, 2, 3 Rubik's units. The area of that side is just 3 times 3. Which is 9. If I go to another one, here's the green side. 1, 2, 3, 1, 2, 3. This one's 9 Rubik's units. And is it just Rubik's units? No, units squared. Area is always in square units because we took units times units. So we've got units squared. So 9 units here, 9 units here. If I go all the way around, blue is 9. Is that gold or yellow is 9. But if I go this side, silver is 9. And this side, I don't know what I call that, rainbow, mermaid, is 9. So we've got 4 sides around and then 2 sides, top and bottom. So we've got 9, 9, 9, 9, 9, and 9. That's 9 times 6. So our total surface area of the Rubik's Cube is 54 units squared. It's area. We've added area to area, but that doesn't change the units. We've got square units plus square units plus square units plus square units. So surface area is just adding all of the units for the area of each surface, adding them together, and that gives you the surface area of the geometric solid. Okay, so as long as you know how to do units on something, then that's pretty easy. How do you find the area of a square or a rectangle? Length times width, we're good. But volume gets a little more complicated. First of all, volume is the amount of space a three-dimensional object occupies. How much space does this Rubik's Cube take up the world? And another way to think of it, I like to think of it, is if I slice the tip top of this off, how much sand or how much water could I put inside this object? Here is another solid. Here's a solid. Now it's not square, it's not rectangle, it's like a circle. Here it's got circles on top and bottom. But if we wanted to find the volume of this, I can tell you what the volume is. They have to tell me right here. 12 fluid ounces, 355 milliliters. But how do we know how much is in there? Well, for what we call a regular shape, we can take the area of the base and then multiply it by the height. So in the case of our Rubik's Cube, what's the area of the base? Well, let's see, the base was like unicorn color or something, right? So what was the area of our base? It was 9. So if this is the base, then how tall is our solid? It's 3, 1, 2, 3 Rubik's units, right? If I'm using my handy dandy ruler here, and I'm measuring graph paper units, it happens to be exactly 10 graph paper units there. That's pretty handy. But if I'm using Rubik's units, I've got 9 area on the bottom, and then its height is 3. So the volume of this Rubik's Cube is 27, because that's 3 times 9, units, Rubik's units. Is it squared? It's squared. It's one more than squared. It's cubed. Cubed, because we had square units, and then we multiplied by another dimension. So the dimension for volume is always cubed units. If you're using centimeters, it's centimeters cubed. If you're using inches, it's inches cubed. If you're using Rubik's units, it's Rubik's cubed. Ha ha, that's where that name came from. So I said for regular shapes, then it's just the base times the width and then times the height. But irregular shapes include spheres and cones, and you see that. Now, a cylinder is regular, and the difference is the base and the top of a regular shape are the same. So our Rubik's Cube, the base and the top are the same. So we can just say all the way up, everything's the same. We take the area of the base, we go straight up, it's the same area on top, so we just multiply by the height. For our Coke can, Diet Coke, I'm trying not to drink sugar, we've got a circle on the bottom, and there's Coke in here, I'm not turning it upside down. We've got a circle on the bottom, we've got a circle on the top, and in between, we have just a straight line. So on the document here, you see the cylinder. The cylinder is an example of a soda can, Monster can for you guys, right? You're not drinking Diet Coke, you're drinking Monster. All right, so a cylinder is a regular shape because the bottom and the top are the same, and we can find the area of the bottom of the top. But look at these two others, a sphere, like a bouncy ball, basketball, baseball, any kind of ball. That doesn't give me sides and tops and bottoms. So I'm gonna have to memorize a formula for finding the surface area and the volume of a sphere. Same with a cone. Think of an ice cream cone upside down. Let's see, I have an example. My husband went digging through the garage. So this is a megaphone. a megaphone. Now it's got the top of it cut off. So we would have to extend this up to say, what's the total cone? And then if we chopped off a piece, then what's the surface area? What's the volume? But we can do that. So a cone is another thing that's irregular. We're gonna have to have a formula for that one, and a formula that we'll memorize. But for a lot of shapes, you're going to be able to figure out how to determine surface area and volume, and you won't have to memorize a formula. You'll just be able to do it. And the great way that we're going to start doing this is using nets. So a net is just a diagram. And I have an example here. A net is a diagram that when you fold it, it turns into a three-dimensional solid. So think of it as our Rubik's Cube. This one right here is our Rubik's Cube, but we tore it apart. We folded it, all unfolded, and flattened it out. Now, if I cut this out and fold it all back together, I'm going to have a cube. So a net is just the diagram. It just lays flat in 2 dimensions, but when you cut it out and fold it, it turns into the 3-dimensional thing that you're trying to figure out the surface area or volume of. So if you look at on the right here, over here on the right over here, here's a net. A net, it's flat, it's 2-dimensional. And then here's the solid that it turns into. So you can see if we use these darker colored cells, squares, as the base, then we would fold up this little 2x2. We'd fold up this little 2x2. This one would fold up, it has to be 3 across to match this base, but when we fold it up, it's just 2 units. This one has to be 3 across. Why isn't it just 2 units up like this one? Well, it's actually 4 units up. It's 4 units up. So these first 2 units are gonna connect with the top of this, the top of this, the top of this. And then these last 2 units are gonna fold over and be the top of our box. The top of our box. Now this is not a full Rubik's Cube, it's only this much of the Rubik's Cube. Okay, so that's a net, and we are gonna work with nets. And that'll be the next video, and that also will be your homework assignment. So this video and this document are informational to help you understand geometric solids, what surface area and volumes are, and how we use nets to help us calculate volumes and surface areas. In our next video, we're going to work with nets, we're going to make some solids, and this will be your homework for the week.